Picture this. You're staring at a quadratic equation, feeling completely stuck. The numbers seem impossible, and you're running out of time. But what if I told you there's a powerful shortcut that can unlock the secrets of any quadratic equation? Meet the sum of roots formula. Alpha plus beta equals negative b over a. This single equation will transform how you approach quadratic problems forever. Today, you'll discover what this formula means, how to use it to solve problems faster than ever before, and see it in action through real-world applications. Before we dive into formulas, we need to understand what roots actually are and why they're so important in mathematics and real-world applications. The roots of a quadratic equation are simply the x values where the parabola intersects the x-axis. These are the points where y equals 0. Watch as we create a parabola. Notice how it curves down and intersects the x-axis at exactly 2 points. These intersection points are called alpha and beta. Alpha and beta are the two roots of our quadratic equation. But why should we care about roots? They appear everywhere in real applications. In physics, roots help us find when a projectile hits the ground. In engineering, they're crucial for designing parabolic reflectors. Here's the key insight. The sum of these roots gives us valuable information about the parabola's symmetry and position. This relationship will unlock powerful shortcuts for solving quadratic problems. Now that we understand what roots are, let's discover a powerful formula that can tell us the sum of the roots without actually solving the equation. We start with the standard form of any quadratic equation. In this standard form, we have three important parts. The letter a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. Here's the remarkable formula that connects the coefficients to the sum of the roots. If alpha and beta are the two roots of our quadratic equation, then their sum equals negative b divided by a. Notice how the coefficients from our original equation connect directly to the formula. The b coefficient goes to the numerator, and the a coefficient goes to the denominator. The negative sign in front of the fraction is absolutely crucial. Many students forget this negative sign, so remember. The sum of roots equals negative b over a, not positive b over a. The beauty of this formula is that it allows you to find the sum of the roots without actually solving the quadratic equation. You simply identify the coefficients a and b, then apply the formula. This formula comes from Vieta's formulas, which are mathematical relationships that connect the coefficients of any polynomial to sums and products of its roots. Vieta's formulas are fundamental tools in algebra. Now that we understand the formula, let's see it in action with some concrete examples. Now that we understand the formula, let's apply it to our first example. We'll find the sum of the roots without actually solving for the individual roots themselves. Here's our quadratic equation. 2x squared plus 4x minus 6 equals 0. Before we can use our formula, we need to identify the coefficients. First, let's identify our coefficients. The coefficient of x squared is a equals 2. The coefficient of x is b equals 4. And the constant term is c equals negative 6. Now we can apply our sum of roots formula. Remember, the sum of the roots alpha plus beta equals negative b divided by a. Step 1. We substitute our values into the formula. We have b equals 4 and a equals 2, so the sum equals negative 4 divided by 2. Step 2. Now we simplify the fraction. Negative 4 divided by 2 equals negative 2. Therefore, the sum of the roots is negative 2. Notice something remarkable here. We found this result without actually solving for the individual roots. Let's verify this result by actually solving the equation to see if our roots really do sum to negative 2. Starting with our original equation, we can factor out a 2 to get 2 times the quantity x squared plus 2x minus 3 equals 0. Factoring the quadratic inside the parentheses, we get 2 times the quantity x plus 3 times x minus 1 equals 0. This gives us roots of x equals negative 3 and x equals 1. When we add these roots together, negative 3 plus 1 equals negative 2, confirming our formula worked perfectly. This demonstrates the power of the sum of roots formula. Instead of going through the entire factoring process, we can find the sum directly using just the coefficients. This saves time and reduces the chance of calculation errors. In our next example, we'll see how to work backwards, using the sum and product of roots to construct a quadratic equation. Now we're going to explore a fascinating reverse approach. Instead of finding the sum when we know the equation, we'll construct an equation when we know the sum of the roots. Here's our problem. If the sum of the roots of a quadratic equation is 5 and the coefficient a equals 1, what is the value of coefficient b? Let's identify what we know. The sum of the roots alpha plus beta equals 5 and the coefficient a equals 1. Now we'll use our sum of roots formula to work backwards and find the value of b. We start with our sum of roots formula. Alpha plus beta equals negative b over a. Step 1, we substitute our known values. Alpha plus beta equals 5 and a equals 1, so we have 5 equals negative b over 1. Step 2, we can simplify this. Since we're dividing by 1, we get 5 equals negative b. Step 3, to solve for b, we multiply both sides by negative 1. This gives us b equals negative 5. Now that we know b equals negative 5, we can construct the quadratic equation. To construct our quadratic equation, we start with the general form, ax squared plus bx plus c equals 0. We substitute our known values, a equals 1 and b equals negative 5. This simplifies to x squared minus 5x plus c equals 0, where c can be any constant. Notice that c can be any constant value. This means there are infinitely many quadratic equations with a sum of roots equal to 5, as long as a equals 1 and b equals negative 5. This demonstrates a powerful insight about quadratic equations and their coefficients. The key insight here is that the sum of roots directly determines the coefficient b. Given the value of a and the sum of roots, we can find b instantly using our formula. This relationship works for any quadratic equation. Now for our third and most challenging example, we'll see how the sum of roots applies to real-world design problems. A landscape architect is designing a parabolic garden, and we need to find a key parameter that will help determine the garden's layout. Here's our problem setup. A landscape architect is designing a parabolic garden, and the equation that describes the garden's layout is 2x squared minus 4x plus 2 equals 0. We need to find the sum of the possible positions in meters. Step 1, we need to identify the coefficients in our quadratic equation. Comparing our equation, 2x squared minus 4x plus 2 equals 0, with the general form ax squared plus bx plus c equals 0, we can see that a equals 2, b equals negative 4, and c equals 2. Step 2, we apply the sum of roots formula. Remember, for any quadratic equation, the sum of the roots alpha plus beta equals negative b divided by a. Now we substitute our values. We have b equals negative 4 and a equals 2. So alpha plus beta equals negative times negative 4, all divided by 2. When we have negative times negative 4, that becomes positive 4. So we get alpha plus beta equals 4 divided by 2, and 4 divided by 2 equals 2. Therefore, the sum of the roots is 2 meters. Now, what does this result mean for our garden design? The sum of the roots, which is 2 meters, represents a key parameter in the garden's layout. This could relate to the symmetry of the design, the positioning of key features, or the overall dimensions of the parabolic shape. This example demonstrates several important concepts. First, the sum of roots formula works for any quadratic equation, regardless of the context. Second, real-world applications show how mathematical concepts connect to practical design problems. Finally, the mathematical result provides meaningful information about the physical system, in this case, helping the landscape architect understand key parameters of the garden's parabolic layout. Now that we've mastered finding the sum of roots, there's a deeper mathematical insight that connects to what types of roots we're actually summing. This is where the discriminant comes into play. The discriminant is a special expression that we calculate from the coefficients of our quadratic equation. For any quadratic equation ax squared plus bx plus c equals 0, the discriminant is b squared minus 4ac. The discriminant tells us about the nature of the roots. While our sum formula alpha plus beta equals negative b over a always works, the discriminant reveals what type of roots we're actually adding together. There are 3 possible cases for the discriminant, and each case tells us something different about our roots. When the discriminant is positive, we get 2 distinct real roots. When the discriminant equals 0, we get exactly 1 real root, which is actually a repeated root. The parabola just touches the x-axis at one point. When the discriminant is negative, we get 2 complex roots. The parabola doesn't intersect the x-axis at all, but the sum of roots formula still works perfectly. Here's the key insight. Regardless of whether your discriminant is positive, 0, or negative, the sum of roots formula alpha plus beta equals negative b over a always gives you the correct answer. The discriminant just tells you what type of numbers you're adding. We've covered a lot of ground today, so let's recap the most important concepts you need to remember about the sum of roots in quadratic equations. The sum of roots formula alpha plus beta equals negative b over a is your powerful shortcut for understanding quadratic equations without actually solving them. This formula matters because it saves you time, works for any quadratic equation regardless of whether the roots are real or complex, and has practical applications in engineering, physics, and other fields. We explored 3 different types of problems to show you the versatility of this concept. In our first example, we found the sum of roots directly using the formula. In the second example, we worked backwards to construct equations from given root relationships. And in our third example, we applied this concept to a real-world garden design problem. If this video helped you understand the sum of roots concept, I'd really appreciate your support. Please hit the like button if this helped you, subscribe for more math tutorials, and let me know in the comments which example was most helpful for your understanding. But we're not done with quadratic equations yet. There's another powerful relationship waiting to be explored. In our next video, we'll explore the product of roots formula and discover even more advanced quadratic techniques that will make you a quadratic equation master. Remember, mastering mathematics is a journey, and you're making excellent progress. Keep practicing, stay curious, and I'll see you in the next video.